Welcome to SketchFormation. In this series, I talk to engineers about how they build and run applications. I interview them on a couple different questions while they describe the app, and I whiteboard it without them seeing. And then at the end, we kind of switch the tables and I reveal the whiteboard to try to explain the infrastructure back to them and see how close that matches to reality. In this episode, I talked to Alex, who works on a product called Smart Edge. These devices are meant to be provisioned in the fields and manage infrastructure at an edge. I'll let Alex describe it here.
So my name is Alex Silver. I'm a software architect at Intel. I work on a product called Smart Edge. So our product is a edge compute platform. It has two major components. There's an edge node we call our product an edge node. It's a hardware appliance that sits on premises at an edge location. It runs different compute workloads, containers, VMs, virtual network functions, mainly any use case that requires low latency, has maybe backhaul bottleneck constraints, compute intensive, will really run on that edge node. And users manage those edge nodes centrally through our controller. So it's a web UI and REST API that the users can interact with to manage whether it's 1, 10, or 100 nodes that they're managing. They use that as a way to kind of do different monitoring actions, management actions, stuff like that on the product. So we've been working on that for the last few years and are in the market with a few really cool customers and just solving some unique edge specific use cases.
Now at this point, I interviewed Alex for about an hour and a half, and we talked about 5 different questions. One was, what is the application? 2, why does it exist and why did you build it? 3 is, how does a customer interact with the application and use it? 4, what could break or what has broken in the past? And 5, how do you roll out upgrades to the service so that when a new version comes out, you don't impact customers? We had a great conversation about all of those things, and at the end, here's the finished drawing and me explaining the infrastructure back to Alex the way I understood it. So I just started out here with a quick little, what it is, at least product name of, what we're describing. Starting up here with kind of the what is the product or what does the product do? I guess I loved your one hop notion for like, this is, the ideal case is we're managing infrastructure that is close to or as close as possible to like something that someone needs to manage, whether that is light bulbs, phones, laptops, whatever the case may be, but also this like other piece of managing this like core infrastructure down here is interesting from a like, you can run more workloads. This isn't just a let me collect metrics from my light bulbs. This is, I actually need to do compute. I need to do things to those devices that's I sometimes need to do in a data center, but you can move that closer. Obviously, to the edge is the key here, where those devices live, and the possibility of 4G and 5G being part of that stack later on for either connectivity or whatever the need is for a user, that you don't have to backhaul everything to say, okay, this is now a data center. It's like, no, this is actually still what we would consider an edge environment. That's cool. And then I liked your MEC, the multi-axis edge computing. Just the thought of this isn't a device that is managing one thing. This is a device that has like one purpose. It is more of a multi-purpose device at this edge location for a user. So here's my let's see, let's get out a little bit. Your day one experience here for like, what are we doing with this infrastructure? I'm a user. I requested a box and I want to do something with it. So the first thing that you said, we need to have an internet connection to this box. And that's first step it's going to do is basically do this phone home to allow me to, once I, as a user, go in and do my registration, that's where this discovery service and update service kind of kick in to make sure that's the the device is registered to me, it's connectable, I can do things to it and constantly connect back to the service, but also this unique ability to sometimes be broken after the initial like, hey, I know you own this device, but I may not always see this device. So that's really interesting. And then this kind of like behind the scenes API of it's AWS infrastructure. It runs, dozens-ish of containers at different scales or whatever. Right now EC2, but possibly moving to ECS or Fargate or something. And a lot of this right now is the fundamental is managed with Terraform for the hosted service, but then also the additional options of the multi-tenant option is here in AWS, but also you can have clones of that pretty simply for a large customer or whatever the case may be that they need privacy or smaller blast radius, that sort of stuff. Does that sound right?
Yeah, definitely. This is awesome.
and then so over here we have this one other like piece that is pretty critical for collecting those metrics and basically funneling those back into your API to gather metrics so that I can view what's going on the service, what workloads are happening, what's provisioned at that edge. And this isn't, I'm assuming most customers don't have one edge device. They might have dozens or hundreds of edge devices. So it's really important to be able to distill all that information down to say, oh, look, US West edge is having a problem right now. Why might that be? So being able to like have a graph and visualize that for a customer helps them, I'm sure, debug things for their own application. Right. And then I also like, I put this updates down here. I like that it's its own service that is kind of special, but also it's the user gets to like pick when it happens as a, it's not something that's forced on them based on, like, oh, well, we have a schedule, like we're just going to do it whenever. As someone who worked at an enterprise, I understand the life cycle and the coordination that's a user of your service has another thing they sell. Like their business doesn't exist to consume your device. Their business exists to give some value to another customer. So you need to give them the flexibility to be able to give that, that value somewhere.
Yeah, definitely. Yeah, we've seen our fair share of people with products that auto update and everything changes for them. And while we would want to do that, if we can avoid that mental relationship of, oh, your product always has a problem upon update and they can't kind of coordinate that, it wouldn't be that great. So yeah, that's really been that's an important one for us.
And yeah, auto updates work in certain risk portfolios and under certain conditions. Again, if I'm a customer and I have hundreds of these, I would be very concerned the day an update went out to hundreds of my devices and I might lose connectivity if there was a problem. So I thought that the possibility of things that have broken or could break in the past was really cool of just like that, the message queue of, oh, how often are you connecting that information? You can do a lot of things to like get either a buffer or whatever the case, to like say, oh, well, I'm just going to send these messages and we're going to store them in Kafka until it comes back or whatever the case. But that also has risk for how you're getting that data, how you're queuing that data. It's another thing that you need to manage that isn't, it's another distributed system. Like reducing the amount of distributed systems you run is pretty important for a lot of people. So the move to gRPC and being able to version those APIs, I'm sure helps you on the back end too, of saying, oh, well, this message is coming from this other version, and you can slowly scale down how you're routing those APIs behind the scenes without needing the customer to like, I need you to upgrade now because all of our infrastructure upgraded. It's like, no, I can keep a couple of those instances around for routing that API version. Is that right?
Yeah, exactly. The headers that are exposed in gRPC, right? The things you can inject in there, even the TLS stuff alone, right? If service A is talking to service B and it's claiming, what version it's on in the message, it can do all of that. And the overhead is low because it's already part of the TLS. It's already part of its communication. So yeah, we kind of use that to go and make a decision about whether a certain endpoint set is being used much anymore. We can really help clean our code base at the same time, kind of a two-way street.
And then the second piece I thought was cool, of just like essentially collecting all those metrics, moving from a relational database like SQL to a time series, and avoiding the I guess thundering herd of data, essentially of we sent too much stuff down the pipe and now we need to process all that, but now we can't read that, and being able to put that in a time series so that it's can compress a lot easier, but also the characteristics of flushing that data to disk in a time series allows you to still have a high read throughput while you're writing the data. So that was really cool. Just like a cool use case of like, oh yeah, this is why it broke for us. I mean, some people are just like, well, duh, use a time series. And it's like, well, like that's not always that easy. It's not always straightforward to just say like, oh, sure, time series. Like there's a lot of decisions to happen there. And if you're running this infrastructure yourself, like you may not have a DBA that knows time series. So it's like, oh, well, now someone needs to be a time series, database administrator and understand how this works and how it can fail. And so a lot of that stuff goes into like, well, what did we decide? It's like, oh, well, we decided based on what expertise we had so that our customers don't go down.
Exactly. Yeah.
And then I guess the final thing here was that upgrades of, interesting that, like people forget that there's maintenance windows still in the world. Like this is still a thing that exists for a lot of customers, and even whether they're they're just worried about it or they like if I had an edge device and I was the NFL and I had a football game that I was like publishing, I don't want you to do a maintenance window. Like I don't care how safe it is. Like I don't need you to do that while a game is or the Super Bowl's on, right? Like we can wait for that upgrade just a little bit or plan for it ahead to make sure that experience for our customers is better. So being able to plan around that is really critical.
Yep.
As well as the whole point of like this can be a maintenance window that you can do for the managed side of it, but it also could be user initiated at any time if they're like, oh well, I'm ready. I don't like they decide on their own. It's not necessarily like you're forcing it on them or you have to do it. So a user can say, oh well, I want this now. Just give it to me.
Yep.
So that's the device management, and then I really like this kind of like workflow down here of what your process of basically CI builds these container images and pushes them into a registry, also with signing, which is very often a thing like I don't really care. Like the SHA is fine, but actually like signing to verify that those bits are correct, not just correct in the SHA sense, but secure and they haven't changed, because if I have access to a registry, I can change that SHA.
Yep.
And so you can keep that securely outside of that registry. So when you do pull it down, you can verify those things. It's really neat. And then just I actually really like the simplicity of like Docker Compose works, right? Like we compose a few of these, this service has two things that it depends on, or they all get bundled together. And it just moves forward. And you can do that, especially at a monthly cadence, like without needing to overthink it and say, okay, well, we need to, and because you auto-gen those compose files, like it's not like someone goes in and like, oh, I need to edit, 10 YAML files and bump a version and do a git push. Like, no, like the generation kind of works for what images are latest and being able to use those as essentially a template for yourself and for customers is really cool. And then I kind of put this like, you have microservices, but because you're currently deploying everything as one version, it's like the monolithic micro rolling upgrades, where it's microservices deployed as one unit, which sometimes requires coordination, but in most cases it just makes everything simpler. That's like the key here of like, well, I don't need a 200 line Jenkins deployment script. Like I just would rather make this as simple as possible, and we'll do a little bit of coordination, especially at smaller scales of if you don't have like hundreds or thousands of developers working on this stuff. It's
pretty easy for a dozen teams to say like, hey, deployment's going to be on this date. If you don't have an update, don't worry about it. You'll still be the next version. We're not going to change your service, but you will get redeployed. Which is that benefit of like, hey, just bugs disappear because they're like memory leaks or whatever the case may be, just kind of go away, which is kind of nice.
Yep.
And then currently, you know, a monthly cadence again is in my opinion completely fine for a service. Even for your backend, I'm sure you don't have customer, like if there's a critical bug or something, I'm sure you can push that out quicker. But in most cases, like, well, we just want to get that feedback loop for the developer. Hey, I don't want to wait 6 months for you to see, did my banner color change from red to blue? But you know, it's good enough to be able to give a regular cadence to customers, because also like you can drown customers in, hey, every week I'm pushing, you know, you a change log. They don't want to read that either, because again, they're pushing their own versions of their own software and giving their customers value. So no, this all seems quite neat as a, like, it works really well for what it is. It makes a lot of sense. I also I don't even think I mentioned like that agent on the core infrastructure, designing that yourself. Like you mentioned, you don't need to redesign like a Kubernetes infrastructure, but a simple agent that can connect back with secure TLS can go a long way of like, hey, I can send RPC messages to you and I can trust that I'm not getting those from someone else that is nefarious or whatever the case. And I know what commands are supported there based on those versions with gRPC headers and everything else, to say like, yes, I can do that, or no, I can't. It's just simple. And it's a pretty well-defined pattern for I need to control a bunch of infrastructure. So.
Yep.
Yeah. No,
this is cool. It looks just like it. It's if we had to put this in a lineup and you had to pick, I think it would be easy.
Yeah, like I mean, in your own diagrams, I mean, obviously you don't have like all of these considerations in that, but I'm hoping that at least like the core components of how the service runs and what is critical to providing that value to your customers is kind of represented here in some way for the customers and for, you know, the engineer developer side of it, of like, oh, I can look at this and I can understand, okay, well, this is roughly why we made that decision or where this thing runs.
Yeah. For us, if diagrams and just even some small write-ups, I love that's my favorite form. You know, I actually do like drawing, but I know you're much better at it. But for me, I just do a little short form write-up, and yeah, it's just explaining these rationales is just as important as making sure they run and implement, you know, are implemented fine, because engineers will come back in 6 months and we'll be like, why are we doing that? And this should be easier. You could do this in message queue. And we just circle backwards, right from the gRPC problem without that kind of, I call them battle scars. They're the reason you went towards that is because you have a mark to show for it. Right. And so, yeah, it's just as important. So yeah, I like drawing it like this. And I think even just writing it out when you're in a moment of realization of moving something around, or even just the simple, the 101 level stuff, writing something up about it is just as good. And you can be super close to the code, or it can just be in your wiki or whatever. I mean, for me, I do both, right? But yeah, that was really cool.
That's it for today's episode. Thank you so much, Alex, for coming on and explaining the infrastructure to me. If you're interested in Smart Edge, go ahead and check out the website here. And I hope you come back next time where we talk to more engineers about how they build and run applications.